All right, in this video, we're going to take a quick look at another example, one that we were introduced to way early on in the Agile Mind curriculum. This was like day 2. It was the very second lesson in Agile Mind, and there was a problem called the bikes and skateboards problem, where you had to try to figure out, right, like there was an uncle who left you in charge of the shop, but it was all locked up, and said, please order 54 wheels for the 21 bikes and skateboards in the shop, and then the phone cut off, and your job was to try to figure out how many bikes and how many skateboards were there with this information. And so we did this a bunch of different ways, right? Like some of you made tables to try to figure this out. Some of you right, just kind of like did some visual representations. They looked at a bunch of different things in the Agile Mind slides. But really, this is another situation that can be best solved algebraically with a system of equations, right? So I did the work here already to try to change this into a system of equations where we have two things, bikes and skateboards. We can again call them like B and S if we wanted to, but Desmos doesn't like that very much, so I just used X and Y. That's pretty common to do. Right? So we said let X be the number of bikes, Y be the number of skateboards. When I add them together, I have 21 things all in total. Each bike has 2 wheels, so the total number of bicycle wheels is 2 times X. Each skateboard has 4 wheels, so the total number of skateboards is 4 times Y, since Y was the number of skateboards. And since we have 54 total wheels, if I add up the bike wheels and the skateboard wheels, I get 54. Right? So with those two equations, we can solve this as a system. And this is one where really it probably doesn't matter which method you use, substitution or elimination. So I'm going to do both here just so that you have an example, right? You can kind of decide for yourself which one you like better. So the first one we'll do is substitution. We'll go back to the old, the first one that we learned. Right. So if I use substitution, I have these two equations, x plus y equals 21. And the second equation is that 2x plus 4y equals 54. All right. I don't have anything by itself here, so I need to rewrite one of these two equations, probably this top one, so that something is by itself here. So let's maybe solve this thing for y. We'll take this top equation, x plus y equals 21, and let's just move the x to the other side. I'm going to take away an x from here, so that I get this. So the number of skateboards is equal to whatever 21 minus the number of bikes is, right? Now I have y equals all by itself, and I can take this and substitute it in for the y there. So that this would become, right, 2x plus 4 times the value I substituted in for y, this 21 minus x equals 54. So now again, one equation with one unknown. We effectively substituted the y away for something that only has x. So now I have just one equation with an x showing up a couple of times. Right? So I need to do some steps to solve this. Right? Let's distribute the 4 across the 21 and that minus x. So I have 2x plus 4 times 21 is 84. Minus 4 times x is going to be 4x. Equals 54. Okay. I have two x's here, right? 2x and negative 4x. Let's just rewrite that. We're going to switch the order of these two so that it's 2x minus 4x plus 84 equals 54 here. And then if I actually do this subtraction, 2x minus 4x puts me into the negatives. Negative 2x plus 84 equals 54. Got the 84 there. I need to subtract that from both sides. So I'm going to subtract 84 from both sides of this equation. So it's going to cancel there, and I end up with negative 2x is the only thing left on the left side, equals negative 30. The last thing I need to do to get x by itself is divide both sides by negative 2. I'm left with x, my number of bicycles, equals 15. Again, not done. I've solved for one of the variables, but now I need to find the other one. The nice thing with substitution is that I already have like a y equals this set up. So I just need to put this 15 in place of the x over here, right? Let's just do that right there. So I have y equals 21 minus 15. So y, my number of skateboards, is just equal to 6. Again, it's always a good idea to go back and check your solutions, right? I used this equation to find what y was, so let's go back into this solution, or this equation here, 2x plus 4y equals 54, and check. 2x plus 4y equals 54, I know has to be true, so let's put in, right, my 15 for x, my 6 for y, and I have 2 times 15 plus 4 times 6. Is this equal to 54? Well, 2 times 15 is 30. 4 times 6 is 24. Is that equal to 54? Yes. Right. 54 is equal to 54. It checks out. So we have 15 bicycles and 6 skateboards in that shop. Okay, so that was using the substitution method, right? You can also do this question using the elimination method, right? So let's show what that would look like here. So again, we'll rewrite the equations. I have x plus y equals 21, and 2x plus 4y equals 54. So with the elimination, the goal is to try to get rid of one of the variables by either adding or subtracting one of the equations from the other one. If I did that right now, though, right, like if let's say I have that x plus y equals 21, let's write that underneath this equation, right? If I tried to like subtract this equation from this one, I really wouldn't eliminate anything. I would be left with 1x and 3y, but nothing would go away. So what we want to do when this happens is, right, I need to try to make one of these numbers in front of the variables match. Right? I need to make them be the same so that when I subtract them or add them, if it's like equal and opposite, they cancel out. So what I have to do then is kind of use my rules of algebra. I know that I can multiply or divide like both sides of the equation by the same number. As long as it's the same number, it will stay true. So what I'm going to do is double that whole piece of the equation here. Like this whole equation, I'm going to double the left side and double the right side so that both sides of this scale doubled and the equation is going to stay balanced. It's going to stay true. And if I do that, okay, let's just write the 2x plus 4y equals 54 up here again. And let's double everything in this equation to keep it the same. If I double the left side, the x plus y, I'm going to end up with 2 x's and 2 y's. 2x plus 2y. And then if I double the right-hand side, the 21, that gets me to 42. Right? So now I have a case where these two things are the same, and I can subtract one equation from the other. Right? Just do a quick, let's minus this whole thing. Basically, I'm subtracting 42 from both sides of this equation. Think of it as a number that's getting subtracted, but 42 is equal to this. So if I just subtract these variables together, that's the same thing. Right? So if I subtract that, 2x minus 2x becomes 0. My x's are gone. They have been eliminated. Right? If I subtract 2y from 4y, again, don't think of this as a plus sign here. I'm subtracting that. So that's going to become 2y left. And then 54 minus 42 is 12. Right. So now I have one much simpler equation to solve. 2y equals 12. Right. Divide both sides by 2. And I'm left with y equals 6. So now I can go back to one of these original equations that I had, x plus y equals 21, to find what my x is. X plus y is 21. Let's put in y is 6 plus 21. Subtract 6 from both sides of that. I know that x equals 15. And again, I should go back and check, right? Just like we did with the substitution. Check it in the other one. I'll do it really quickly here. 2 times 15 plus 4 times 6, is that equal to 54? Right? It's the same thing that we did last time. Right? Yes, 54 is what I get when I do that. So that's my check for the system, right? So pros and cons to both things here, right? The elimination is a little bit more maybe conceptually tasking. You have to like recognize what you have to do. I have to multiply both sides of this by 2 to get it so that something matches here, so that when I subtract, it cancels. But it doesn't have, like, I don't have to worry about any distribution here, like the 4 coming across both of these things, especially if this was like a negative sign. The elimination is a little bit more direct. I get straight to this, like one equation with one, right? There's just a y here. It's not showing up in multiple locations like when I do the substitution method. So you get to decide for most of these things. But yeah,